All right, so this is lesson 10A, the counting principle. Um, in this first slide is where it has everything, the concept of the counting principle. Hopefully you will understand it by doing a real life situation example. So here's the lunch special. You see taco trucks out there and they always have some kind of special. Or you go to my Italian, your favorite Italian place, the Chico's. On Friday, sometimes I go to the Chico's and they sometimes have a special of the day. Anybody ever gone to the Chico's and had some special day over there? No. So anyways, in this particular situation, you get a main dish and it's probably right there by the sea or something, by the beach, and you got a main dish for this lunch special. You can get a fish taco. It's a big fish taco, a big asada taco or a chicken taco. You're gonna choose one of those, and for some reason you could only choose rice or beans, not both. And either you're gonna get a Coke or water. So how many different meals are there possible for the lunch special? Does anybody have an idea of things they know? What would it be? Throw out a number.
10.
Huh? 10? All right, let me kind of just do it by doing a what is it called? A tree diagram. We're gonna do a tree diagram. So what's gonna happen here is like, let's do the main dish. Let's suppose that you like fish. Let's go with fish. All right. So this particular person went and said, you know what, I like fish. All right. You took your main dish. Then let's go with your side. What do you want? How many choices you got? Rice or beans? So you could go with, let me put rice on top first, or you could have gone with beans. But let's say that you went with fish, rice, and then after you chose rice, you're gonna go with what? Either what? Cocoa water. That's all there is, or water. But you could have gone this other way and done cocoa water. See, as it is already, you see there's what? 1, 2, 3, 4. Well, we could have done it with what? Asada taco, no? And then done the same thing. I'm not going to do it, but you could do this thing again. You see this whole thing, no? Here. So are you going to multiply 4 times how many are here? Well, there's 3, no? Chicken. Asada chicken. Here's chicken. So what is it? Do you want me to do this one too here? I don't want to do it. Oh man, rice and beans. Beans. You see what I'm saying? It's already so, what is that called? Tedious to do it this way. I'm already getting tired. Cocoa water. It's cocoa water. And I'm going to do it over here again, and I don't want to do it. Okay? So there's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because I don't want to do it. What's an easier way to do this? What's an easier way to do this? You got how many choices you have? Well, you're going to have to choose a main one, a side, and a drink. So let's do it like this. And I'm already putting something in between here. How many choices do you have for the main dish? How many? 3. 3 choices. You're going to pick one out of them. How many choices do you have for a side?
2.
And for a drink? And the counting principle means that you multiply. So that is the easiest way to do it. 3 times 2 times 2 is what? 12. There's 12 different meals without doing a tree diagram. And that is basically the whole lesson. And we're done. Pretty much, that's what it is, that you multiply. If you want to add another thing here, let's say we add a what? What kind of taco you want to add? Fish, asada, chicken? It doesn't really matter, no? Like say we want what? Pork? What is it called? Pork? I don't know. Pork? Let's say they want to add what? Rice, beans, what else? Anybody, just to... Rice, beans, what would you want on the side?
Ensalada.
Huh?
Ensalada.
Ensalada. Salad? Instead of that? And they're expanding this. They're saying, hey, you know what? Let's expand it for some people that are healthy. What else? Coke, water, what else? All right. So in this situation, how many choices would you, how many different meals can you make out of this? If it was like this, what would it be? So you got 4 times what? Times 3 times. And the answer is 36, isn't it? Yes? You get the idea, no? That's the idea. That's it. The idea is that how many different meals are there possible for the lunch special? In this one, you have 3 choices. You don't have to write that down. You have 3 choices for the main dish, 2 for the side, 2 for the drink. Then you can just set it up like this, where the main idea here is you're multiplying. Should be right here, like a dot. Multiply 3 times 2 times 2 is 12 different meals. And here, if you want to write down the actual counting principle, this is what it says. These are events. If an event has n possible outcomes and another independent event has n possible outcomes, then all you got to do is multiply all the possible outcomes of each, and that would be all the possible events together. Yeah, that's it. It doesn't. It's not just m times n, because it's saying two scenarios, but it can go on and on and on and on as many different events. All right, that's it. Let's go. So now you're gonna have a chance for extra credit today, because we only got like 7 weeks left of school, somewhere around there. So now I will give extra credit, and I'll put it in. Ready to go? If not, you can go to my website and write down the notes if you missed anything. Let's go. Here we go. Problem number 1. Copy it down. It's getting hot in here. Let me turn that thing on. That's too easy. I can't give extra credit for this one. That is too easy. So a pizza comes in 4 sizes. Say you got a personal, medium, personal, small, medium, large, or something. And then you got 3 possible crust types. Say you got a thin, deep dish. What's the other one? What's another one? Deep dish. This is another type of crust or whatever it is. And then 10 possible toppings. You got what? You can just have pepperoni. You can have just pineapple on it. You can just have jalapeno on it. Just one topping. And so how many one-topping pizzas are there possible? Of course, you got all these possibilities, but more likely than not, probably everybody just is going to pick up a pepperoni pizza, no, or something like that. You're not going to pick some weird one. Some people do. Who got the answers? Okay, how many one-topping pizzas are there possible for this situation? Shout it out. 120, isn't it? 120? Easy. Why? Because first you got to choose, you got 4 choices for the size of pizza you want. So you're going to put 4. And then you got 3 different types, and then of crusts, and 10 possible toppings. Making it 4 times 3 times 10, which is 120 different one-topping pizzas from the given information. All right, here we go. Here's the one. Has there been a person that answered this correctly in all my years of teaching? Maybe there has been 1 or 2. Here's problem number 2. Extra credit on this one. In how many different ways can 5 questions on a true-false test be answered? In how many different ways can 5 questions on a true-false test be answered? Extra credit on this one. Raise your hand if you think you already got it. In how many different ways can 5 true-false questions be answered? 5 questions, and each one of them is a true-false question. You understand what I'm saying, no? You understand what it is, no? It's just, but how many different ways can you answer it? Raise your hand. Who's going to do it? Who wants to ask credit? In how many ways can you answer it? In how many different ways can you answer that test? I said raise your hand. I said raise your hand. What do you think it is? You said it was 32? It is true. That is correct. But I was waiting for people to say what? Is it 10? Is it 20? But it is. Why is it 32? Why is it 32?
Because true and false help you to multiply by 5 times.
Multiply by what?
Multiply 2 times 2
Yeah. So basically, look, we can go problem 1, problem 2, problem 3, problem 4, problem 5. You don't have to. You can go ahead and do true. You can do instead you can do false. You can do false, true. You can do okay. There's I'm not even gonna do it. But it's gonna go all the way to 32 different ways. Okay, why is this true? Because they're independent of each other. That's what this whole lesson's about. I do not care about what's going on here. How many choices do I have? What can it be here? True or false, isn't it? So I got a total what? 2. And it's just what's happening in the next question. So that's going to be 2 to the 5th is 32. That's correct. That's the answer. And so it's sometimes it's like against what you think makes sense. You're like, why is it not 10? Because it's not what you think it makes sense, but it's not. Because you're not applying this counting principle. All right, let's go to number 3. A password is made up of 6 letters, okay? 6 letters, and then followed by 2 digits, and all the letters and the digits can repeat. How many possible passwords are there? Or how many passwords are there possible? So yes, even more so than ever. This right here, passwords, is important nowadays. I just came back from Mexico, and so the Wi-Fi over there is not secure. And in a couple days after I came back from Mexico, I got a message from iPhone and somebody saying, "Hey, all your stuff is in what is it? What was that message? That it's compromised." And go ahead and change all your passwords and this and that. And I don't even know. And I'm like, all right, quickly change all my passwords to different numbers. And I don't know. And so why is this important? Because you just watch right now. A password is made up of 6 letters. So 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots for the letters, and then you got 1, 2, all right. And so now this idea of the counting principle, it's each event. You got this is 1, 2, 3, 4. They're independent events. So what could go here in the first one? Okay, how many letters? It's talking about letters. We just want to put letters in there. How many letters are there in the alphabet? Huh? How many letters in the alphabet? Anybody know how many letters? So 26? So 26. Now, what goes here? 26? Because it would be dumb, but you could put A is allowed because it says they all could repeat. So, but it's all these 26 different letters. You could do A, B, C, D, E, F if you wanted to. That's what it's saying. And now, it's going to be followed by 2 digits. So how many digits are there? How many digits are there? 10. Starting with what? Starting with what number? 0. Isn't it 0 a digit? A single digit? 0. So that counts for one of them, no? 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on, what did I do? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a total of 10 of them. And it starts with 0 to 9. So that's going to be 10 of them. And then another 10 of them. So go ahead and multiply that out. Get your calculators and multiply that out. And it's going to come out to some weird number. The calculator and even decimals, let's try to put it on decimals, it still gives me the same number. 26 times 26 times 26 all that times 10 times 3. No, it's big number, big number. It's a big number. All right, let me tell you what that big number is. It's this number right here, 26 to the 6th power times 10 to the 2nd power, and that number is that number right there. Okay, so that number right there. Different passwords that could be made. So that number is, who knows how to read numbers, big numbers? Read that, who knows how to read this number? Huh? Who knows how to read this number? 30,891,000,000. Millions. All right, look. There's 30,891,577,600 different passwords. Another way of looking at it is this many. Watch. Roughly, and I'm going to round. 30,891 million different. And I'm yeah, that's like a. Well, you know what? This number, the amount of money that Elon Musk has is 5 times bigger than this number. Beyond, like, he's not going to spend, yeah, he doesn't need all that money in his lifetime. I don't know. Anyways, that's a lot, no? But for encryption, this is nothing. For encryption, they're in just astronomical numbers. So this is still very small for making up a password. All right, let's move on. Let's move on to the finish up the lesson here. And what are factorials? We're gonna move on to factorials. What are factorials? Problem A, 4, and it looks like a very excited 4. Very excited 4. And all this is called 4 factorial. And 4 factorial is counting backwards, but multiplying the numbers. So what is that? How do you count backwards? 4, 3, 2, 1? But multiply them. So what's 4 times 3 times 2 times 1? What's 4 times 3 times 2 times 1? 24. That's all it is. So what can you do with factorials? You can do what? 5 factorial, get that answer for 5 factorial, then multiply it by 3 factorial. So 5 factorial is going to be 5 times 4 times 3 times 2 times 1. 5 factorial is 120. And then we multiply that by 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. And so that 120 times 6 is, what's 120 times 6? 720. We can also do this. We can divide factorials. You got 5 factorial divided by 5 minus 3 factorial. You got 5 factorial. 5 factorial is 120. We just said 5 factorial is 120. 5 minus 3 factorial. 5 minus 3 is 2 factorial. 2 factorial is 2 times 1, 2. So now you got 120 divided by 2. 60. All right. Number 4. In a certain year, the Kentucky Derby had 15 horses running in the race. How many different possible outcomes of first, second, and third place finishes were there in the competition? So in about a month, there's going to be the Kentucky Derby, and I always try to watch it whenever I have a chance because it's really exciting. The people that watch horses run, it's pretty cool. And sometimes they even make movies out of it, where like the one that is the least likely to win was Seabiscuit. Anybody know about Seabiscuit? I think it's a movie about some horse that it was like not the favorite and ended up winning or something like that, the race. So they all got chance, but they usually do have a favorite. There's usually a favorite, a couple favorites. So in any case, let's say that they all got a chance, no, and they all do. How many different possible outcomes of first, second, and third place finishes were there in this competition? And why are we only concerned about first, second, and third? Let's say, which might not, that the first place gets $1 million, second place gets 500,000, and then the third place gets 100,000. Everybody else go home. No, they get nothing. So you better get first, second, and third, or you get nothing. So okay. So in how many different ways can they finish first, second, and third out of those 15? You guys got calculators. Look at you do some more. You guys doing it. Who thinks they got the answer already? You guys got calculators. You got calculators. Who's gonna give it a shot? Extra credit. Extra credit. Who's that? You didn't come up with a number?
I got
90. That's not it. That's not it. Somebody else? It's kind of a big number, yeah? No, more than that.
3,375.
Close. Close. It's close to that. What'd you get? What you got? $2,000? Yeah, that is correct. That is. All right. Look. How many spots do we got? How many are like, hey, we only got what? One stop, first place, second place, third place. What did I say? Don't they all got a chance? Even the least favorite, they all got a chance. How many could win first place? Once somebody got first place, how many could, like, okay, well, somebody already got it. How many got? That's it. That makes sense or no? Because once they all got a chance, somebody already got it, then the leftovers and leftovers. And that's 2,730. And lastly, this is the last problem of the day. Number 5, a Camaro, a Mustang, a Challenger, a Civic, and a Tesla are running a race. How many possible outcomes are there if you specifically want the Camaro to finish first and the Mustang to finish last? Basically, the Camaro will certainly finish first. And for sure, the Mustang will finish last because I did something to the car, so it's not going to run that. You know, I cheated or something. So we know for a fact that my car is going to finish first. That's my Camaro. That's my car. It's going to finish first. And then the Mustang's going to finish last. So how many different ways are there possible for this scenario for them to finish the race? Who's gonna give it a shot? No extra credit? Nobody wants extra credit? Extra credit? How do you know? How can you explain that? How do you know that?
I guess.
You always want to reason it through. So it's all the cars are going to finish the race because it's not going to. One of them is going to have an accident and not finish it. See, sometimes you have to really be specific with it that they all do actually finish the race. So there's 5 cars, and they're all going to be some kind of first, second, third, fourth, fifth. So I already know that my car, the Camaro, is going to finish first. So that's gone. That one's going to go here. And this one's already going to finish Mustang. I don't know. It's going to finish last. There's one of them out of all. So now, how many could finish second? That makes sense now? So it's going to be 6. The answer is 6. And this is still very basic, but some of these problems just get really crazy hard. And that is it for today.